Greeting to everyone. This is Rajeshwari, working as Assistant Professor in the Department of Computer Application in Bishop People College. Today we are going to discuss about the topic types of data structure. What is data structure? It is a way of organizing the data. Not only consider the data stored, but also the relationship to each other. Data structures are two types. One is linear data structure, another one is a non-linear data structure. Linear data structure is a way of organizing the data in linear way. Non-linear data structure, the data structures are not arranged in sequential manner. Linear data structures are stack, queue, array and linked list. Non-linear data structures are trees and graph. Linear data structure. In linear data structure, data elements are arranged sequentially. Data elements are linked one after the another. In linear data structure, single level is evolved. The examples are array, stack, queue and linked list. Non-linear data structure. The non-linear data structure, the data elements are arranged not linearly, sequentially. Data elements are attached in hierarchical manner. Here, multi-level is evolved. The examples are trees and graph. Stack, it's a linear data structure. It is otherwise called as first in, last out or last in, first out. Stack has only one end to insert and delete an item in the stack. That end is called as the top of the stack. Here, two operations are performed in stack. That operation is push and pop. Push is inserting an element into the top of the stack. Pop to delete an element in the top of the stack. So, the examples are stack of chairs, book, plates. So, what the last chairs we arrange to take the first, and first chair is take out the last one. That is why it is called as last in, first out or first in, last out. Next, queue. Queue is a linear data structure. It is called as the first in, first out. In queue, we have two ends. That is, insertion are taken place at one end and deletions are taken place at another end. That end, the inserting an element is said to be a rear end and deleting an element in the queue is said to be a front end. Here, two operations are performed in the queue. That queue is NQ and DQ. NQ means inserting an item into the back of the queue. DQ means remove an item into the back of front of the queue. So simply queue is said to be the waiting in the ticket counter. First come, first serve. Here, first who come first, they have to serve first. That is why there is a queue. Queue is a linear data structure. Okay. Next data structure is a array. Array is a linear data structure which is a finite collection of similar data items stored in consecutive memory allocation. Then a set of pairs which has index value. The index value is started from 0 to value stored. Two important functions associated with that: store and retrieve in values. Linked list is a linear collection of data elements called nodes. Linked list is a linear data structure. Linear order is maintained by pointers. In insertion are very difficult in sequential representation because there will be a data movement. In linked list node contain two parts. One is a data part, another one is a address part. In the data part, it stored the value. Address part stored the address of next node. Next node address stored the next node address value. In linked list, data can be represented by node, node containing data and link of next node address. Okay, linked list in data structure. Linked list. A node contains two parts. One is the data and the link. So the next node address stored in the next node address. In the 8 node contain the addresses of first node. The last node contain the address values. That is a linked data structure. In the linked data structure is three types: singly linked list, doubly linked list and circularly linked list. In singly linked list, the head pointer is there, contain the first node address, and node contain two parts. One is a value and a data and address of the next node. Store the next node address, store the next node. Last node contains the null value. It is a simple linked list that is called as a singly linked list. In the doubly linked list, a node contains 3 parts. Node contains 3 parts. Node contains 3 parts. First one is the data part. Next one is the previous address node. Next node address. So in doubly linked list, the node contains 3 parts. One is the data and the previous node address, and then one is the next node address. In the start node is the head node. It stores the first element, first node address here. The first node, we have no previous node address. In the next node address, we store the next element node address. Next, in the next node, it is a previous node address we stored here, and next node address we store the next element node address here. The same one. The last node contains the next node address will be a 0. So, which node contains the next node address is 0, null, it is considered as the last node. That is a doubly linked list. A circularly linked list. Circularly linked list also, a node contains 2 parts or 3 parts. It is the last node address pointing the first node. That is why it is called as circularly linked list. Non-linear data structure. So, non-linear data structure, data are not arranged in sequentially. It is arranged in hierarchical manner. So, one at a time. So, tree and graphs are the 2 examples of non-linear data structure. So, trees are the non-linear data structure. Trees are the first node is said to be a root node, next one is a last. With no children's node is said to be a leaf node. Trees will be in hierarchical structure. What is the definition of tree? Tree is a finite set of one or more node, that is a root node. Remaining nodes are partitioned into the disjoint sets, that is a tree. So, we have the node and edges. Connecting the node is said to be a edges. Basic terminologies of tree. So, degree of a tree. The number of subtree of a node is said to be a degree of a node. So, A first considered as a root node A have 2 subtrees B and C. That is why it is a. So, degree will be a 2. Next, B have 2 nodes. So, degree will be a 2. C will be a degree will be a 2. Okay. The leaf node with 0 degree, 0 degree is said to be a leaf node. Okay. Next, terminal or leaf node. So, a node with 0 degree. Node with 0 degree is said to be a node with 0 degree is said to be a leaf node. Okay. Next, sibling. The children of same parent is said to be a sibling. The B and C are siblings because A have the same parent, and D, E are siblings because B is a parent of D and E, and F and G are siblings. C has the same parent C. Next, grandparent. So, D's grandparent is A. So, the parent is here. Okay, D has a parent B, B parent is A. So, D have the grandparents of A. Grandparents of G is A. Next, degree of a tree. Maximum degree of a node is. So, degree. So, what's the degree of the node? A contains 2 parts, that B and C. So, the degree will be 2. Degree will be 2. B have degree 2. Then C 2. F and G higher, so degree will be 2. And D have no degree because no other nodes are informed here. So that is a degree G. Ancestors are the nodes along the path from the root node to that node. That is the ancestor of G. What was the ancestor of G? What is the ancestor of G? So coming from the path A and C. A, C. So ancestor of G means, so are all the nodes along the path from the root node to that node. That is said to be an ancestor of G. Okay, level. The root node level 1 and node at level next node is B is a level 2. Next node is level 3. Some, for example, so level of children nodes is 1 plus level plus 1. For example, so the level will be next node here formed H, I, J, K. It's coming in. So let's start from the level 1. Root node is level 1 and level 2 will be B and C. Next node is intermediate. Level 3 B. Next H will be level 4. So this is called as level of the node. I10 path of a tree. Maximum level of any node is the height or depth of the tree. So the maximum level of this tree is said to be level 3. So height of the tree is 3. So that is the height of the tree. Okay, forest. It is a set of n greater than or equal to 0. It is joint set. Remove from the node, then we get the forest. Remove the root node. Remove the root node, forming the forest. That is said to be a forest. So, summary. Today, what we discussed in that, what is meant by data structure? It's a way of organizing the data. Not only consider the data stored, but also the relationship to each other. So, two types of data structures are here: linear data structure and non-linear data structure. Linear data structure means the way of organizing the data linearly. Non-linear data structure means the data are not arranged in sequentially, in hierarchical manner. The examples of linear data structures are stack, queue, linked list and array. Non-linear data structures are trace and graph. So these are the things we discussed in today. So thank you.